Hello and welcome to this tutorial about Midas Gen. I am Cyprian from Midas IT, and today we will design together a multi-story steel building following the Eurocode 3 into Midas Gen 2015. So Midas Gen possesses the following features for steel design. You can do code checking for beams, columns and bracing as per Eurocode 3. You can check ultimate and serviceability limit states. You can do load combination and they are automatically generated as per Eurocode 3. Static wind loads. You can do static seismic loads and response spectrum as per Eurocode 8. You have a lot of available sections, joint connection, imperfection, which needs to be considered, second order effects, internal forces and moments, composite beam design, and capacity design. So in today's tutorial, I will not detail the first part, which is too theoretical, but the second part is the tutorial. So I will go and I will first load the model in Midas Gen, then show you how you can select your design code, then how you can generate the load combination and check design parameters that interest you, and change the values like the embrace length, the moment factor, etc. Then I'll show you how to enter the deflection limits, to check the design results, and finally to change and update design sections. Let's go briefly over the following slides. You can stop the video anytime to watch them in details if you're interested. Okay, now we go into the part 2, the tutorial. So let me talk about the model that we will analyze first. So first of all, Midas Gen provides the following two methods. The first one is the program finds optimal sections for gravity load, so by doing design still optimal design, and also find optimal sections for lateral loads, and with the combined use of the two, the user should find the optimal sections. The second method is the program checks the strands and the serviceability based on the sections defined by the user and the design code selected by the user. Also, the program searches and proposes sections which satisfy the design conditions entered by the user. Then the user can update the sections referring to the sections proposed by the program. So in this tutorial, we'll use the method number 2. So here you have the details about the building that will be analyzed, and here you have the codes and the applied loads, so self-weight, flow loads, wind loads, seismic loads. You have structural system with bracing system, material, beam column and braces, and those are the unit load cases. And the applied sections, and that's it. So now let's open Midas Gen and start the tutorial. Okay, I just opened Midas Gen 2015. Now the first thing I'll do is to open my project. So the project has already been built, so I will not show you the modeling, I will only show you the design phase today. So I will try to put the link with this model and the PDF in the comment section of this video. So if you don't have it, go in the comment and download it. Okay, my building is now displayed. So you see that the section has been hidden, so if I activate them, I have a view of the model like that. So now let's start the tutorial. Now the first thing I'll do is go in analysis and perform the analysis. So the model has not been loaded with the results, so I have to recalculate everything. And this will be pretty quick. Okay, it's done. So it took 4 seconds. So now that I have the analysis results, I can go in the design tab where most of the action will take place in this video. So you see that in the design tab here you have steel design. So I click here and I will choose first the code that I will use for the steel design. So I'm using the Eurocode 305. But if you want to use other codes, you can also use those codes. So click on OK to be sure that everything is defined correctly. And now the next thing I'll do is to generate the load combinations. So for that, go in the Results tab and go on the left, you have the load combinations. So you can generate load combination for different type of design. So here I will do steel design, so I select steel design tab, and I will use directly the function called auto generation, and all these loads will be generated automatically according to the Eurocode. So let's check that the options are defined correctly. So I'm using the steel code of Eurocode. I'm using a gamma. Okay, that's the right value. Click on OK, and as you see, I have all my loads generated. Now maybe what you're wondering is I would like to change a few parameters before the checking. So I'll show you how to do that, to select specific sections, for example, in your model, and change the embraced length. So you have for that, go into the view, for example, and in the selection tool check identity. You can also select the button here or here. So it's the same thing. So now in the tab you can select specific section by selecting section here and just select like that. So I'm pressing the control key of my keyboard to select both and then click on add, and you see in red in my model those section has been selected. So I can close this. I can close this window and then go in the design tab, steel design, sorry, not steel design, general design parameter, and here you have the embraced length. So let's add and replace, and for the lateral embraced length let's enter value of 2.5 and click on apply, and you see the value of the embraced length has been modified. Now let's change the equivalent uniform moment factor. So you can go directly in the menu here and find it. So it's here, equivalent uniform moment factor, CM, and this time you can select all. So I will use simply the button here to select everything of my model, and I will ask the program to calculate that. Click on apply, and that's done. Now let's enter the equivalent moment factor for a specific type of element, the beam. So to do that, let's go in steel design where you have this equivalent moment factor CMLT, and I will select using the same method than previously. Select identity and choose beam, and you see that only the beams have been selected. Click on close and just choose calculate by the program and click on apply. So before we enter the serviceability parameters, let's confirm that the serviceability load type combination is correctly defined. So for that, go in design, general design parameter, and you have serviceability load combination type. So now you can check quasi-permanent, frequent, and characteristic, that it's correctly defined. Close that, and now we can go in the step where we have to define these serviceability parameters. So let's select the beams in the model first. So I'll use select identity beams like that, and then let's go in the design tab, still design, and enter the serviceability parameters in this window. So check OK, add and replace by selection. The deflection control for beams is L divided by 250, and the deflection for the columns H divided by 300, and that's OK. Let's click on apply to apply that to my model. Okay, now everything seems to be ready, so let's do the still code checking. So design, still design, and still code check. So now we have to wait a bit that the software read the code instead of you. That's much faster. And he will check all the members of this building. So I like this function, it's wonderful. I don't have to open the code and do that by myself. Okay, and now I got a nice table like that, and the software basically is telling me that the two properties here are not valid, so they are not verified. So you have two types of visualization. You can view by member, where all the members of your model will be listed, or you can view by property like that. So how to do when you have that? Well, let's do the graphics. So let's put that in big. So now we see in this window that the actual resistance here is a bit higher than the value authorized, and here as well in the combined resistance the R max is a bit too large. So we'll have to do something about that. So let's come back to our code checking results dialog, and here you have a button called change. So what this command will do is that it will verify the strands for the user selected sections and save the design results until reanalysis is performed. So I have two sections selected, so let's click on this change button. So let's view what we have here. Limit combined ratio from 0.8 to 1. That's good. Now click here in search a satisfied section, and you have all the sections that appear. So let's select first the section, this one, HEB 340, and let's change it. Okay, so now you see here in the message window that the change of the section has been done. So let's do the same from the property number 6, which was not verified as well. So we have the same limit combined ratio. Let's view the different sections, and let's change this section. So change and close. Okay, and that's done. So now Let's view the graphic. Let's select again first the section and let's view again the graphic. And now you see that the actual resistance is verified and the air max is verified as well, so everything is wonderful. So now that we've verified that, let's update the design section. So we have this too. Let's click on update, and in this side you have properties before change, and so it represents the sections used in the analysis right now, and here the section after change. So let's select this to section and let's click here. So it tells you that the analysis design result will be deleted. Yes. And now you only have to do reanalysis, so it will reanalyze everything. And recheck. Okay, that's done. Now let's view the result ratio. And the thing is that I have one section with a low ratio, so I will definitely change it. First, let's look what we have. Section number 2, the ratio limit 0 to 0.5, and show the result. So now we see that this is the steel code checking result ratio, so the ratio combined and the member. So all the section here have a low combined ratio. So let's now select the elements and close that. Close. Now what I'll do is I selected all these sections that I want to change. So the only thing that I have to do is go in the walk tree, select the new section, drag and drop it here, and this will be automatically assigned to the section that have been highlighted in red. So it asks me, do I want to delete an result analysis? Yes. So now what I'll have to do is simply to perform again the analysis. So let's do that. Now let's do again design code check. Okay, let's view again the result ratio for the property 2, the section number 2. Okay, this time ratio limit between 0 and 1. Show the graph, and you see that now the lower ratio combined is almost 0.7, so that's higher than what we had, and that's great. Okay, that's all for this tutorial. I hope you enjoyed it. as much as I enjoyed it. And see you next time for the next video. Goodbye.